Good afternoon, everyone. I'm Isaac, and I'm excited to chat with you about the world of large language models, or as the cool kids call them, LLMs. We're going to keep things at a high level today, so no equations, no linear algebra or math of any sort. Today is about exploring the current landscape, future trends, and the challenges that lie ahead in the world of LLMs. So, a bit about myself. I've been at Clarifai for over 3 years, now focusing more on scaling our AI platform to production loads and bring new capabilities to the platform. Previously, I was in the aerospace industry. I did my undergrad in NSci at U of T, for those who might know. I'm currently based in Tallinn, Estonia. If you'd like more details or a way to contact me afterwards, you can scan this QR code and reach out to me on LinkedIn. As for Clarifai, where I currently work, our mission is to provide a full stack AI platform for developers to quickly get AI into production. Clarifai is deeply integrated into the operational core of what the industry now calls an LLM stack, which we'll talk about more later. Our customers span over public and private sectors across use cases like snap and search, visual inspection, and content moderation, just to name a few. Moving into today's topic. When we talk about LLMs, everyone knows about ChatGPT. But what about these? It might not be obvious at first, but aside from being cute animals, these are also popular LLMs. Let's do a brief recap on how LLMs became so popular. As you probably know, in the not so distant past, ChatGPT became quickly a household name and one of the fastest products to reach 100 million users. This is before Threads was launched. Within a few months, Llama and subsequently Llama2 came out and stole all the attention, pun not intended. The authors of Llama2 claimed that it outperformed open source language models on many external benchmarks, including reasoning, coding, proficiency, and knowledge tests. But the field has not stopped growing after Llama 2. New models, and especially better performing models, pop up very often. The current LLM leaderboard, for example, this one hosted by Hugging Face, is almost constantly being updated. It's really a testament to how rapidly the field is evolving. We see newer models that are trained on more data and can handle longer input sequences while keeping the same number of parameters. While these are all exciting and get the most attention, the plumbing under the hood to enable training, deployment, and inference are what makes these LLMs usable and hopefully in production. We generally call this collective plumbing an LLM stack. So, what exactly is an LLM stack? It's the infrastructure that one needs for training, deploying, and using these LLMs. You may be familiar with an ML infrastructure stack, which may look something like this. While the models themselves get a lot of the spotlight and hype, we are painfully aware of how much data and compute are needed for developing useful models. The layers in the middle here arguably make or break the day-to-day operations of an ML team. I doubt that anyone would want to deal with this versioning method. For the LLM stack, it's largely similar. In simple terms, it can be more or less summed up with a few layers. Firstly, there's data. This includes all data for training that are labeled or unlabeled. In most use cases, raw data is ingested through a pipeline that extracts structured information, for example, images into embeddings or text into tokens, then word or sentence embeddings. Next is the storage. This layer handles storing both the raw or processed data in databases like a VectorDB. Those are purpose-built databases to handle storing, indexing, and retrieving embeddings in an accurate and scalable way. The model layer is often known as model hubs or model zoos. This layer is closely linked to the data layer as well as concepts like orchestration and infrastructure as part of the data pipeline where scaling is involved. Fine-tuning, training, and model deployment and development are part of this layer as well. Finally, the API layer allows users to access the models for application building. This is the LLM stack landscape as of mid-October in 2023. The fact that I had to say when it's from shows how quickly this industry is evolving. While this could be one person's opinion of how the landscape works or looks like, the general theme remains the same. We are approaching a rather crowded time of choice abundance. There are many offerings where one can mix and match, or integrate these providers and maintain them one by one. So we've been talking about the now for a while. What lies beyond the current landscape of LLMs? What trends are shaping the evolution of LLMs? The first trend I want to talk about is multimodal capabilities. When ChatGPT first came out, we could only communicate it through text. While that was very exciting at the time, it quickly felt quite limiting. So the next big thing is all about integrating various modes of data, like images, audio, and more. For example, you can use images alongside text as a prompt to the LLM. You might have seen this demo from the OpenAI developer livestream a few months ago. It was shown that GPT-4 was able to generate the code for a functioning website from just an image of a mockup. Multimodal LLMs, or as some say, large multimodal models, LMMs, are also able to understand the context of an image and respond in a seemingly logical manner. In this example taken from a Llava model demo, it's being asked what is unusual about the input image, and as you can see, it gives a pretty good response. What makes enabling multimodal capabilities difficult is data availability and model architectures. For data availability, it usually takes a long time and a lot of resources to gather quality data. For model architectures, research needs to be done to learn how to capture the relationship between different modalities in a meaningful and contextually relevant manner. The second trend is customization and personalization. Just like how Iron Man had Jarvis and Joaquin Phoenix had an AI girlfriend, personalized AI has been a popular sci-fi trope in recent decades. We're not quite there yet, but we do see a rising trend in customizing and personalizing LLMs for specific tasks, domains, and people. Imagine an AI that understands not just general queries, but speaks your language, and it's tailored to your industry and preferences. Whether you're in finance, healthcare, or just need a friend, the LLM would become a powerful tool that is able to cater to your exact needs and wants. For instance, you might remember around the end of March in 2023, Bloomberg GPT was introduced. This model could generate Bloomberg query language, which is used for accessing and analyzing financial data on the Bloomberg platform. It could suggest news headlines, and according to its authors, it blows similar sized open models out of the water on financial NLP tasks. One of the main concerns here with customization is privacy and security. How do we personalize models without compromising user data? You may have heard about ChatGPT's first data leak in the news earlier this year, and shortly after, Italy banned its use citing privacy concerns. Are governments being overly cautious? What about enterprises? Well, the survey says less than a quarter of enterprises are comfortable using commercial LLMs, citing concerns about sharing sensitive or proprietary data with commercial LLM vendors. This is leading to increased interest in privately hosted open source alternatives. Of course, the concern is not limited to users and developers, but is also shared by lawmakers. The EU, for example, is likely to be the first to make many data and AI-related regulations as the MEPs further the talks on the first AI Act. The third trend is that LLMs will get faster, lighter, and more efficient. One of the biggest criticisms in training and using LLMs is the sheer amount of power and hardware needed. It's obvious that as practitioners, we feel the cost of training and using LLMs. Training Llama2's 70 billion model required 1.7 million GPU hours. Since NVIDIA A100 GPUs were used, if those were rented at $150 or $2 an hour, compute cost alone would be around $3 million. We can compare this with home energy consumption. According to Stats Canada, an average household in 2020 used about 11 megawatt hours per year. This means that the power used to train GPT-3 can power 116 homes for a whole year, or a small town like Aurelia for a day. That's why efficiency is paramount in the future of LLMs. The push for faster inference and training, coupled with smaller model sizes, aims to reduce their environment footprint while enhancing performance. It may be difficult to find the right trade-off balance between size and accuracy. To help with this, companies and organizations are focusing on the development of new algorithms and hardware optimizations. One of the example of such methods is for fine-tuning LLMs is LoRa, where the number of trainable parameters is drastically reduced. Using this parameter-efficient method, the AI for Finance Foundation developed FinGPT, which surpasses Bloomberg GPT's performance in just half a year, while costing only $100 compared to the $1 million price tag. The fourth trend for LLMs is broader language support. One of the weaknesses of LLMs right now is how limited their language support is. If you're like me, whose mother tongue is not English, you might have tried out ChatGPT using a non-English language. The result wasn't that great, and it's shown in a recent paper that from the availability of that it's worse on low resource languages. However, expanding language support poses challenges, from the availability of diverse language datasets to addressing nuances and cultural context accurately. Efforts are underway to improve language inclusivity and support for underrepresented languages. Aya, Bloom, and No Language Left Behind are some of the past and ongoing projects on this topic. But of course, these exciting trends come with their fair share of challenges, which we'll dive into next. In addition to the challenges that are brought on by each emerging trend, there are a few overarching challenges faced by LLMs, their users, and creators. The first major challenge we face is openness and trust. As you can see from here, proprietary models are still leading in terms of performance. These are no different than black boxes, and some don't even have a technical paper. Users do not know what data is used to train these models, what underlying biases exist, and the model architecture. The creators hold these as trade secrets, and we as users will just have to trust them. One of the biggest features of open models, such as Llama2, is the fact that anyone can access their weights, read the model architecture, and build and iterate upon it. The transparency allows biases to be discovered more easily and creators to be held accountable for the development of the model. The challenge is then to get open models to catch up in performance and ultimately normalize their usage. Open source AI is not a new concept. As of July, Meta seems to be leading the pack amongst big names on Hugging Face when it comes to the number of public models available. Open source is also becoming popular for LLMs because it promotes community involvement and trust. By making these models open source, it fosters a sense of community and collaboration, allowing experts from various fields to contribute, refine, and improve these models. This collaboration not only enhances the model's performance, but also ensures its robustness and versatility. It's also about transparency. By providing access to the underlying structures of these language models, the community aims to build a more transparent foundation for future advancements, learning from past experiences with opaque models. A recent paper assessed 10 major foundation model developers on something called the Foundation Model Transparency Index, which is based on 100 indicators across 13 main aspects. It seems that none of them are higher than 60% on average, so there's a lot more work to be done on this front. Obviously, open models are a way forward to improve trust in LLMs, but as far as what's needed to be done, To make this happen, I'm sure we'll find out more in the next few months. The second challenge that looms the landscape of LLMs is the issue of hallucinations. The model essentially is making things up. It could be quite harmless when it's inventing a fake book title, but quite dangerous when it's providing incorrect or misleading information. ChatGPT is known to have cited non-existent academic papers in its responses. One example was two lawyers were fined and escaped potential disbarment after using ChatGPT and citing non-existent cases. While one could argue that this comes down to doing our due diligence and not trusting the models too much, this is still a prominent problem that needs to be addressed. Hallucination happens when language models extrapolate beyond their training data, creating content that appears plausible but lacks grounding in reality. This is a crucial issue because it reduces the reliability and trustworthiness of LLMs, and by extension, systems powered by LLMs. It's not ideal for a model to tell us fiction, especially when we depend on it for accurate information. The AI research community is actively working to mitigate this problem. One of the ways is to use prompt engineering. Reasoning, and specifically chain of thought prompting, is an example of prompt engineering. This is similar to asking someone to rethink their answer after they have just blurted out a response in a rush. Often it comes in the form of a simple addition of a sentence at the beginning that says, let's think step by step. If you can see on the left side here, the left side of the slide here. Other times, like in the middle column, some in-context examples are provided to the LLM to help it understand the task. But these are often task-specific and require manual efforts. A recent paper from October, represented by the column on the right, aims to generalize prompting to scenarios where there are many tasks without the need for any in-context examples. Another promising method is retrieval augmented generation, where LLMs rely on a separate knowledge base rather than solely on its internal knowledge. RAG has shown to give more accurate results. This is also a way to sidestep the limit on LLM cutoff dates and use it on up-to-date or domain-specific knowledge. It's a fascinating area with a lot of active research and certainly a challenge that needs to be addressed as we move towards to more sophisticated AI systems. As we grapple with these challenges, it's imperative for us to recognize their real-world implications. The future of language models is not solely about technological advances, but about responsible innovation. Each challenge we address today contributes to shaping a landscape where AI is powerful, interpretable, and environmentally conscious. So, in closing, we play a big role in the future of LLMs. For builders, users, decision makers, as we chase for performance and privacy, our collective choices will help guide LLMs to be more trustworthy, more transparent, and more suitable. Thank you very much for your time today.